Now, these are the basic definitions which we covered, but time to time, if any new words will come, I will definitely try to explain it, or you can just point it out also. So we are starting with the safeguard. So safeguard, basic definition of safeguard is any device, system, or action that would likely interrupt the chain of event following an initiating event. That is a safeguard. So again, we go back to our first example. There is a reactor, reaction is going on, and there is a initiating event. Let us consider that human error operator opens the full valve in the steam supply line. So there is an increase in the temperature leading to runaway reaction, pressurization, damage, release of flammable chemical. So here, suppose there is a human error. So there is a cause, or we can say initiating event. So in case of that, we can take the safeguard as a training to the person, records in the log sheets, all these things. So just be careful. This is a safeguard. When we go to IPL, this may not be IPL. So that will discuss in the independent protection layer. But at the time of safeguard, we can consider training, we can consider SOP, we can consider records in the log sheets, we can consider the temperature alarm also as a safeguard. So these are all the devices that will interrupt the chain of events. So say, let us understand it, how it interrupts. So suppose there is a training. So because of training, that human error will not possible, that we consider in this as of study. Suppose there is alarm. So there is, because of alarm, operator will see the alarm and will just check cause of high temperature. He will reach to the steam valve and he will check the valve. If it is full open, they will close the valve or partially keep the open. So that is the way he will interrupt the chain of the events. The chain of event here is manual error, increase in the temperature, runaway reaction, pressurization, damage, release, and fire. So this is the chain. So he will break the chain by hearing the alarm, then taking the action. Similarly, pressure alarm also may be there. There will be control loop also. So high temperature will close the steam supply valve if there is a XV or control valve. Again, if there is a high pressure, so there may be a PSV. So in case of PSV, that will release and reduce the pressure and achieve the pressure and reduce the damage and eliminate the damage of the equipment. So like that, all these will interrupt the chain of the event, that is ultimate consequence fire. That will not reach up to the fire. So that is a basic understanding of this safeguard, how it acts following an initiating event. So initiating event is human error or X stuck open. So now second part in the safeguard, effectiveness of the safeguard. So as I discussed earlier also, safeguard cannot be quantified due to the lack of the data. So as I said, that in the case of safeguard, it may not be recordable. So like say more temperature, we say no more temperature, or in our example also, temperature increase. So if operator is not writing down in the log sheet, so that can also be the safeguard, that we are monitoring the temperature. That is a part of the SOP. But SOP says that we have to monitor the temperature, but operator, there is no instruction or there is a log sheet to write down the temperature readings of that reactor or that equipment. So in that case also, this is also a safeguard, but in case of protection layer, that may not be. So that we will discuss later on. So in this case also, we consider the SOP for temperature monitoring as a safeguard, but since record is not there, so cannot be quantified due to the lack of the data. So we cannot see the trend of change, but of course, randomly operator will observe the temperature, but it will not be able to know what is the trend. It is increasing, decreasing. So that is we cannot quantify the temperature in this case. Second part, uncertainty as to independence or effectiveness. Yeah. In case of safeguard, we are not sure whether this will be effective or its independence. So say for example, if there is there is a transmitter of temperature and pressure, same operator responding to the alarm, so it's not independent. So we don't check normally in the safeguard when this the safeguard is independent or not, and is it effective or not. Say suppose, let us take the example that there is a fire and gas detector installed in the plant. So we take the safeguard credit for the fire and gas detector, but if fire and gas detector installation is not based on the fire and gas mapping study basically is used to ensure that all the areas are covered. Means suppose say for the example, we are taking example of gas detector. So normally there is a range for each gas detector that covers the range. Say for suppose example, we say our gas detector is covering the 5 meter, and we install total four say fire and gas detector in four corner. So our area is say 50 square meter or 100 square meter. So in that case, this 5 meter diameter gas detector will not cover all the areas. So best way to ensure the coverage, we do the fire and gas mapping study. In our case, we have installed the four fire and gas detector in four corners, so we can consider this as safeguard, but effectiveness may not be there. Some of the area may miss. So that is why effectiveness of safeguard, uncertainty to the independence of the effectiveness of the safeguard, because we don't consider all these things in mentioning a safeguard in the HAZOP study. Of course, in layer of protection, that's a different fundamentals, so that we'll discuss later on. If third part is not considered as an independent protection layer, so that is the basic difference in the safeguard and protection layer. Now about the safeguard, purpose of safeguard, protect people, asset, environment, and reputation. Same thing, but effectiveness, independence not applicable. So sometimes safeguard may not be effective, may not act when required. Reduce the likelihood of hazardous event. So definitely we are taking. Basically, there is a basic difference between safeguard and protection layer. As I discussed, in case of the protection layer, there is a probability failure on demand that we refer CCPS. So there will be 10, 100, maybe. In general, we can say there is a one layer. If there's a 10 probability failure demand, so there's a one layer. If it's 100, so there's a two layer. In case of safeguard, we consider one credit or one layer for the PSV also. All the whatever we take the safeguard, we consider only one layer. There's a probability change in the one layer. Like there is a failure in 10 years, so we can take it up to 100 year, then 1000. That's a one layer. So probability of failure on demand maybe once in a 10 years or once in a 100 year or once in a year. So there is a limitation of safeguard, that is we consider always one layer, maybe PFD 100, maybe 1000, but we consider one layer only in the safeguard. While in protection layer, that vary based on the available table. So that's the limitation of safeguard also. Limiting the severity of the consequence. That's again, that is applicable to both HAZOP and LOPA also, safeguard and IPL also. So provide layers of defense in process safety. Of course, it's a layer of defense. In case of any risk assessment, it's a layer of defense. In case of any risk assessment, reduce the likelihood of the hazardous event, but approach is different in the HAZOP and other risk assessment. So in general, for safeguard, the purpose of safeguard is to protect people, asset, environment, and reputation, reduce the likelihood for the hazardous event, limit the severity of the consequence, provide layer of defense to the process sector. These are the basic objectives. Mistakes in safeguards. Identification of safeguard, double counting safeguard. That's alarm and same operator. As I just shared the example that pressure transmitter and transmitter training must be required, like for the protection layer. So in that case, training means not only giving training, but effective training. So effective training means we should have a training metrics. From that, we should have training program, annual, monthly program also. And in case of classroom training, and post training evaluation, and criteria should be achieved, like 75% of people should pass with a 75% mark, then that's a successful training. So this thing, maintaining target of the training hours for each employee, all this gives effective training program. So effective training program is there. In that case, in other risk assessment methods, we consider this as a control, but in safeguard, of course, without training, effective training also, we can consider this as a safeguard, as a control. Next point, our reliance on manual intervention in fast developing scenarios, of course. So normally in the case of safeguards, we consider a lot of manual interventions like operator involvement, like temperature increase, he go and close the valve, pressure increase, he go and close the valve, he monitor, he write down in the log sheet. All these are manual interventions. So in case of safeguards, manual interventions are accepted, but in case of other controls may not be. So that company defines their procedure for other risk assessments also. But nowadays, normally most of companies are switching over from the safeguard as a control to the protection layer as a control. So that helps them to reduce their efforts also. LOPA can be partially completed in that case. So that is why people are switching over from the safeguard concept to layer of protection. So in general, type of safeguards. So of safeguards, active or passive, preventive or mitigative. So preventive and mitigative, active and passive. So let us see one video first, then I will explain these safeguards in detail. So start with first, this is a preventive safeguard. Just please see it properly. Then you will be able to understand why it is preventive. This is the safe way. Actually, first one was the unsafe conditions, or we can say there was no safeguard, but now there is a lotto. Hey, somebody working on this machine, completed back here. So person when he comes to start that particular machine, he saw the lotto, so he checked with the other person, are you working there? So this is the preventive which prevent the cause of that accident. So in case of mitigative, best example is PP. Let us see that example also. So here a person wears the helmet. If anything falls from height, so he is protected because of that. But here cause falling, we cannot prevent the falling, but we can we can mitigate the effect of the falling object. So that will not injure the head of that person moving below that particular area. So here falling cannot be prevented, but effect of falling is prevented through the PPE. So this is a mitigative, protective. We can say protection or mitigation. Mitigation of the severity. So that falling object has the potential to damage the head or give the injuries to the head, but because of PP, that injury is protected or mitigated. So that is the basic difference. In preventive, we prevent the cause of particular that initiating event, but in case of mitigative, we mitigate or we reduce the effect of that particular cause. Like falling is a cause in second case, and we reduce the effect of fall that has the potential to injure the person, but that can be reduced by the helmet. Similarly, in the first case, machine has hazard itself, and cause is the rotation part, that is the cause. But we provide, when we provide the lotto, we use the lotto, so that machine cannot be started, so rotation cannot be started, so that is the cause that can be prevented through the lotto. So that is the basic difference between preventive and mitigative safeguard. Let us take another example. Increase in the feed flow. There is a reaction, raw materials are being feeded. There are 2-3 raw materials. So increase in the feed flow to the reactor cause a rise in the temperature. So that is the basic cause. Suppose there is a ABC3 reactor, increase in the flow of A raw material cause a rise in the temperature. The temperature increase leads to increase in the pressure, leading to the damage of the reactor and result in the release of the flammable chemicals and vapor resulting in the fire hazard. So that's the basic that's the first example which we discussed in the beginning. So here, if you see, there are two colors, green and red. So increase in the feed flow to the reactor causing rise in the temperature, increasing lead to the pressure. Up to here, there is a control. We can control if we have the controls, like we have the feed flow control, we have temperature control or temperature alarm, pressure control or alarm. That comes in the preventive. But after leading to the damage of reactor, after damaging the reactor, there is a release, and release we cannot then prevent because of high pressure damage and because of that release. So here red color is related to the mitigation part. So whatever actions, whatever controls we have in the red color sequence, that mitigate the effect of the release. Fire can be prevented if there is no, so can be say fire can, in case of, if there is a fire, then we have the fire protection system that reduce the effect. If we prevent the fire, in that case, we don't have any ignition source, so that can be the preventive part. Reaching to the fire, then we don't have any control. So there we use the control as a mitigative protective safeguard or controls. So preventive versus mitigative. So list of the layers of defense. So we have the, in particular example, we have high temperature alarm and interlock to close the feed valve. Pressure safety valve on the reactor to release the overpressure. We have high level alarm of the flammable gas detector and plant shutdown. Firefighting system, emergency response. The first three green color controls are the preventive controls and safeguards. Red color, it's because after releasing, we don't have any control to prevent the fire. In that case, whatever actions like high level alarm of flammable gas detector, so that will detect the flammable gas. Early detection, we can prevent the fire also. So firefighting system, so we can reduce the effect of the fire. We can contain the fire within that particular area. Emergency response plan, of course, do the same action, but administrative control. So green color can be the preventive, should be the preventive, and red color is the mitigative. So that is the basic difference between the preventive and mitigative. Okay, so this is all about the safeguards. Now we are switching over to protection layers, independent protection layers.